All right. Well, a little loud. Welcome, everyone. I'm Rob Cochran. I'm a senior product manager at AWS, and I look after Amazon FreeRTOS. So we launched just earlier today, and Amazon FreeRTOS is an IoT operating system for microcontrollers. Now, I know it's getting kind of late in the day, so thanks for being here. And we've got a couple great guests and a lot to get through, so I'll just go ahead and jump right in. I'll start with something that I think we can probably all agree on, that this is not a cake. Now, it has many of the ingredients you'd like to make a cake, and maybe you know what sort of cake you'd like to make. And you probably know some people who'd be more than happy to eat it. But there's work to be done. If we apply the same logic to this photo, this is not a connected door lock. Again, it has many of the components you would use to build a connected door lock, and you probably have a pretty good idea of how to get it done. But there's work to be done. So our industry talks about tens of billions of connected devices. And when we look at that number, the vast majority of them are going to be microcontroller-based. And that's simply because microcontrollers are useful for embedded applications. They sell for low cost, they take very little power, but they also have limited memory footprint. And so it makes it harder to connect these devices to the cloud. So when we look at these challenges that exist today, I think they, to us, fall into sort of three categories. The first is the speed with which developers and OEMs can bring new connected devices to market. The second is the complexity that they're addressed by when they look at the ecosystem that they want to build around their connected products. And the third is the cost of actually adding connectivity to their connected devices. So if we first take speed, developers of Linux-based or kind of cloud, mobile, and smartphone applications have come to expect a certain level of abstraction that allows them to really focus on their core applications and not really think about the underlying connectivity. They usually have tools for security. And that allows them to really focus on differentiating features of the applications they build in the cloud or on smartphones or on PC. The same is not true of microcontrollers. And historically, that's been for very good reasons. These devices have trouble running the sorts of stacks that are required to get connected to the cloud. And so developers and OEMs have had to be experts in this. And that takes time to incorporate. And it means less time spent on differentiating features for their products. Now, many of the OEMs we've spoken to also manage multiple product lines across many generations and distribute these products globally, which introduces a lot of complexity in their supply chain. So the problems of moving quickly are kind of multiplied when you look at different hardware, different software, and different tools across each of these product lines and managing that on a global scale. And the last piece is cost. Any OEM knows that every percent margin is really important to their product. So when you add the silicon that can enable connectivity, you're making a gamble that those features will pay off. And without the ability to differentiate, because you're not, you want to move fast, and the complexity, that means it's harder to make that cost-benefit analysis and have it pay off. So earlier today, we announced Amazon FreeRTOS, which is an IoT operating system for microcontrollers. And it's really targeted at focusing on allowing developers to get to market faster, minimize the complexity in their supply chain, and reduce the cost of embedded development, making more microcontroller-based deployments possible. So we started with the FreeRTOS kernel, which is the most popular real-time operating system for microcontrollers. We then extended it with device software that enables connectivity, both locally into the cloud, security, and the ability to update your devices remotely. We then built a set of associated cloud services that facilitate the use of this operating system. And lastly, we did this with a broad set of partners that you'll hear from a little later on that allow you to take this operating system and apply it to multiple product lines and across device generations, and do so in a consistent way that minimizes the amount of rework you have to do each time. So I want to go into some details of the device software and cloud software that we've built and how it will enable OEMs and developers to get to market a little bit faster. So again, we began with the FreeRTOS kernel. And I'm happy to share that Amazon has taken on stewardship of the FreeRTOS kernel. Richard Berry, the founder and creator of the FreeRTOS, has joined our team as a principal engineer. And we will continue investing in making it a great embedded operating system. So it's been in the market for 14 years. It already runs on billions of microcontrollers, everything from satellites to automotive to coffee pots. So FreeRTOS is already very widely distributed, well-tested, and used across a range of industries. And we wanted to start with this foundation so that we could build something that works really consistently. And today, I think we have something really exciting to share about FreeRTOS in particular, is we're announcing version 10 of this software. So it comes with an MIT open source license. I think this is a big improvement over the modified GPL v2 license that it was previously distributed under. This will be important for OEMs who have existing constraints on the type of open source software they can use. We've also added new features for interprocessor communications like stream buffers and message buffers. And then we've all made this extensible with a set of libraries that enable connectivity on microcontrollers. So you can connect directly to the cloud via AWS IoT Core. You can connect locally to AWS Greengrass or another hub device. And it's all built with a foundation of security, TLS, key management, and code signing that enable you to build securely connected devices. So first, connectivity to AWS IoT Core. Now, for those of you that are familiar with the C SDK, this offers much of the same functionality that included, but it's now integrated with the operating system, which gives you a dedicated task for MQTT, so you don't have to worry about porting the C SDK into the operating system. It gives you device shadow support. I think this is really cool for microcontrollers because battery-powered devices might not be connected all the time. And what device shadows do is allow you to program against a virtual representation of your device in the cloud and not have to manage the intermittent connectivity to your device. We've also integrated with AWS IoT Device Management, which we launched earlier today, that gives you the ability to group these devices and apply actions and device jobs to them remotely. And we've facilitated the use of this functionality with a set of demos that get you started quickly. And so this will really be the fastest way to get started with IoT microcontroller development. But we know that not every use case will connect directly to the cloud. Some IoT deployments happen in remote areas, like mines, and they won't always have connectivity. So you might have a set of sensors on a vehicle that report data to a local hub, pre-process that data, and then when the truck gets out of the mine, it would actually then share that data with the cloud. We also know that there are sometimes requirements for keeping data on site. At hospitals, for instance, sometimes they have to keep records of the data generated by IoT devices. And so Greengrass offers this functionality today, and what we've done with Amazon FreeRTOS is introduce a Greengrass discovery library that allows the device to reach out to the cloud, establish which Greengrass core it should connect to, and then connect directly to that Greengrass core to share messages on the local area network. So again, we wanted to build this with a foundation of security tools that enable developers to deploy securely connected devices. Now this starts with secure sockets using TLS. We also require certificate-based authentication, both with the cloud or if you're choosing to connect to Greengrass. We also taken a modular approach to our development and a standards-based approach. So we used PKCS11 for key management on the device. And coming soon, we'll offer the ability to sign firmware updates down to your device. so OEMs can have confidence that only their devices will run their code. So in addition to the FreeRTOS kernel and the libraries we've built for the device, we've developed a set of associated cloud services that facilitate the use of Amazon FreeRTOS. Coming soon, we'll give you the ability to deliver over-the-air firmware updates to your device. Using AWS IoT device management, you can select a group of devices based on certain logical characteristics. So you could select all devices with hardware number 123, software version XYZ, and then upload a new firmware image that you want to apply only to that group of devices. You can then sign that firmware image and stream it to the device over MQTT. The device then has code running on it that will validate the code signature and provides APIs to the developer to manage the reboot and installation logic. One thing that I think is particularly interesting about this is that because microcontrollers are particularly memory constrained, we've done this all over the existing TLS connection with AWS IoT Core, meaning you only need to maintain a single TLS connection to be able to update your devices. The Amazon FreeRTOS console will be the quickest way to get started with Amazon FreeRTOS. By selecting one of the supported hardware and the libraries that you need for your use case, we can give you a project download that allows you to open that project in your IDE, enable a demo, and get started very quickly. And so returning back to how we enable driving a faster time to market, I want to kind of talk a little bit about the architecture and how we approach this problem. So we worked very closely with partners on the type of hardware we would support and what drivers we needed so that our operating system could run consistently across a range of devices. We then developed a set of internal Amazon libraries, and developers are free to access those. But the idea was that we would then provide simple interfaces at a higher level of abstraction that the developer could access directly. Again, in the cloud space, in the mobile space, and in PC space, developers expect this kind of abstraction today. That's not true for microcontrollers, and I think that's at least our goal when developing Amazon FreeRTOS, is to give that same level of experience so developers can focus on their differentiating features rather than just getting connectivity reliably working. So to share a little bit more about what we've built and what the impact is for developers and for OEMs, I'm very excited to welcome Chris Green on stage, who I've worked with over the last month or so. And we've been very excited to work on this project together. So Chris Green, lead firmware engineer at Schlage.
Thanks, Rob.
Welcome.
Thanks for this fantastic opportunity to help unveil Amazon FreeRTOS. In 1909, Walter Schlage received his first patent for a door lock that turned a light on and off. I think he was a little ahead of his time for smart home automation. And now we have locks that communicate with the cloud. The IoT service provides the level of security that Schlage locks are known for. With TLS visual authentication and conditional protection policies, we can securely control access to the cloud. The notion of the shadow provides a great way to handle devices that may be offline for some time. And the addition of Greengrass extends the reach to edge devices that may not directly connect to the internet. The embedded C SDK was a good introduction to the IoT service and provided the framework for us to integrate communications using the MQTT protocol. To give you some background and a comparison of the effort to get up and running with the IoT service, I'd like to share some of my experiences that began almost 2 years ago. My initial evaluation of the embedded C SDK was done on a TI CC3200 Wi-Fi launchpad. Fortunately, TI had created a port for the SDK, so in about a day after some research, reviewing the code, installing the IDE, and compiling the shadow example, I had the dev kit talking to the IoT service. So my next task was to get the SDK running on an existing system. This system was running FreeRTOS on an NXP Micro with a TI 3100 Wi-Fi chip. To accomplish the task, I needed to adapt the 3200 port to the 3100 and create a FreeRTOS task to handle the SDK integration. So in a couple more days, I had the SDK running on this existing system. So now fast forward to a little over a month ago, Amazon contacted Schlage and asked if we would help evaluate this new operating system. Let me tell you, I think you're in for a real treat. As I was looking through the code, I thought, wow, a lot of the work that I previously did has now been included and integrated as part of Amazon FreeRTOS. So what does Amazon FreeRTOS mean to companies like Schlage and developers like me? It means that we now have a better way to quickly, securely, and predictably launch an embedded system that communicates with the IoT service. Amazon, with the partnerships that Amazon has created among multiple hardware vendors, integration time is eliminated. So this time around, to evaluate Amazon FreeRTOS, I used a TI CC3220 launchpad. The operating system includes the board support package, so finding and adapting a port wasn't needed. Amazon FreeRTOS extends the FreeRTOS kernel with integrated modules for secure sockets, Greengrass discovery, crypto libraries, and shadow control. There's an included FreeRTOS task to handle the MQTT communications, and several example tasks that illustrate various IoT service functionality. Coming soon, as Rob mentioned, there will be integrated support for over-the-air updates using the MQTT protocol. So it will no longer be necessary to manage multiple ports, sockets, and protocols to retrieve an image from a file service such as S3. And icing on the cake is the Amazon FreeRTOS code signing feature. With the code signing and AWS certificate management service, securely signing an image for over-the-air updates couldn't be easier. So in summary, my evaluation of Amazon FreeRTOS was very positive. The amount of time to get a dev kit up and running and talking to the IoT service was reduced from around a day using the old SDK to less than 2 hours using Amazon FreeRTOS. Having a stack that is integrated with the FreeRTOS kernel is a huge benefit and big time saver. Code signing and over-the-air updates using the MQTT protocol are brand new features that didn't exist before. And having support for multiple hardware platforms increases the modularity across embedded devices of various sizes. So in the end, Amazon FreeRTOS helps Schlage secure security and spend more time developing features that bring value to our customers rather than managing the complexity of product build and delivery. Thank you.
Thanks, Chris. So I'm excited to share both the experience Chris had with Schlage developing a prototype of a new smart lock, but we also have customers developing prototypes across a range of devices. Hive Smart Home has developed a water leak detector using Amazon FreeRTOS. Honeywell's built a demo of a connected thermostat and a controller using Amazon FreeRTOS. And if you visited the IoT State of the Union earlier, or maybe in the Builders Fair, you would see NASA's JPL puffer robots navigating a Martian landscape running FreeRTOS. But it's not just these use cases. Microcontrollers are already used across a wide range of industries, and we see applicability in each of them, from oil pressure sensors to smart meters, fitness trackers, appliances like washing machines, robotics. You'll even hear from a partner later who provides a solution for safety-critical use cases, like medical devices and automotive. But one thing Chris hinted at earlier is that broad support for hardware is critical in building out this product family. Because Schlage doesn't make just one product. They make many products, and they have many versions of the same product. And so hardware proliferates, the type of software that they implement on this hardware proliferates, and then it has different tools to support the use of that software and hardware. And so when we started out with Amazon FreeRTOS, we wanted to take a similar approach that the FreeRTOS kernel took for many years, and really do it in collaboration with many of the biggest semiconductor vendors. So we've worked with Microchip and NXP and ST Microelectronics and Texas Instruments to develop a way to systematically create supported hardware. And we did this by defining not only the APIs for customers and developers to use, but a standard set of interfaces to the board support packages, and enabling them to write software that supports the use of our operating system across a range of devices. And so this should help give developers a really consistent experience when using Amazon FreeRTOS on the hardware they want to use, and expose the best features that each hardware platform has to offer. So to talk a little bit more about both his experience with the FreeRTOS kernel over I think more than a decade, and then what the partnership means with Amazon and NXP, I'd like to welcome Jeff Leese on stage, Senior Vice President of Microcontrollers at NXP. Thanks.
So as the world's #1 vendor of microcontrollers, having shipped about $3 billion this year, NXP is intensely focused on driving edge node processing, bringing edge node processing to you, your personal devices, your home, your car, your office, and beyond. Starting over a decade ago, working with Richard Barry and the team, we had a belief that open source OS deployment on the MCU platform would be the thing of the future. And we've seen that today as FreeRTOS has become the OS of choice on our MCU platforms today, above proprietary systems. It's effectively established the eminence of open source software on low-cost 32-bit platforms. But so far, the distance between the edge node and the cloud is further than you'd think. In the decade before the arrival of edge node, our industry shipped a combined 200 billion microcontrollers into the market, the vast majority of which were not connected. In the last several years, the rise of edge node has driven more and more connectivity, but we don't see the deployment of full edge node to the cloud. And the reason for that is that the gap is tough today for the developer. The developer has to bridge that gap and work with the challenges. And sometimes those challenges mean that they skirt around the issues of security and scalability. And with the media attention on that, we believe that that's kind of holding the IoT landscape back. So it's so important, we feel, to create the framework for a secure, connected, edge node compute model. Bringing Amazon FreeRTOS together with our secure SDK is really the great starting point for bridging that gap. with the inclusion of secure connectivity, extensive web services, cloud services, provisioning, and future over-the-air updates, Amazon FreeRTOS is the perfect complement to the MCU Expresso SDK. Now, this is our first AWS IoT platform, available now. If you're interested, we have a lot to give away today, so just stop by. The first platform is based on our LPC family of microcontrollers, the 54018, but coming soon in 2018, extensive deployment across our MCU platforms. Also the leading IMX-RT high-performance crossover processor, which is a 600 megahertz MCU, moving to a gigahertz in future, will drive huge functionality gains at the edge node for the MCU platforms. And this will be the key enabler of that. AWS IoT Core service has been leveraged to provide the back-end connectivity to our sprinkler application here. We've adapted a standard sprinkler application, graphical sprinkler application, and created a connected version by using the device shadow functionality of IoT Core. This allows you to bring connection between your smartphone and the graphical application. And you can see here we can mirror changes between your smartphone app and the application. Changes made at either the target's user interface or on the smartphone screen are mirrored, and vice versa, via the AWS IoT Core. So with MCU Expresso SDK and Amazon FreeRTOS, the cloud is now much closer. Thanks.
So in our attempt to enable a faster time to market for developers and OEMs and create a cleaner level of abstraction for microcontroller developers, we know that we can't go it alone. So you heard from Jeff and what we've done with hardware partners, but it's also about building out an ecosystem and tools that enable the use of our operating system. So ARM's done this for a very long time in the market, and I'm very happy to welcome Paul Williamson on stage, who's the Vice President of IoT Device IP at ARM, to share a little bit more about what that means.
Thanks very much.
Thanks.
So, thank you. So just quickly, wake things up a little. Raise your hand if you've heard of ARM. Are you confident you know what we do? Keep your hand up. Okay, not bad. ARM's been around for about 25 years. And in that time, we've been responsible and working with our partnership to create some world-changing innovations. And in that 25 years, we've shipped around, with our partners, over 100 billion devices. And they are purely the IP that goes into the core of the processors that are in many of the microcontrollers that you see out there in the 32-bit world, but also in our smartphone devices. The game changer for us is this acceleration towards IoT. That means we expect to see that 100 billion that has taken 25 years to occur again in the next 4 years. So the acceleration in growth is incredible. And just to put it in context, 100 billion devices is one for every person who has ever lived in the history of humanity. So that is a phenomenal number of devices that will roll out over the next 4 years. As I said, we haven't done that alone. ARM has done that working with over 1,000 partners across an ecosystem of tools, components that are required to build all of these systems. But we stand here at that precedent of 100 billion devices in a not great shape. We're at the threshold of a risk of ending up in the insecurity of things. And cybersecurity could have been and has the potential still to be a mess if we don't, as a community, engage to solve this problem. And so it's exciting to be here today at the kind of launch of initiatives that drive towards solving this problem. But ARM as a whole is really trying to embrace this challenge for the entire industry. And we've done that by publishing a digital social contract, which you can have a look at arm.com, which is calling on everybody who's in the tech ecosystem to take ownership of this challenge and understand that it's not enough to build a shiny device and ship it. We own the challenge of the entire life cycle of that device. There are many other industries where, we ship automotive industry cars. The people who ship those cars own that product and have a responsibility for it beyond the showroom. You don't expect wheels to fall off, and you have somewhere to go back to if that doesn't happen. The same isn't true in tech today, and we're asking the ecosystem to step up and embrace that challenge and improve what they're doing. And it's exciting to see AWS recognizing that challenge and putting the tools in place to enable developers to meet that goal. On top of that, we believe in the need for intelligence from the edge all the way to the cloud, a shared goal that you see in Amazon FreeRTOS. So we see the need for security across the system. It's true that we expect to see that from the cloud, but also down into the Greengrass environment, the A-class in the ARM terminology, gateways and hubs that will control these devices. But we want to see that security propagate all the way to the heart of the devices at the very edge of the network. So we're investing at ARM in bringing improved security into the core of every device and making that a key feature of every microcontroller device that will be shipping in the future, and improving on that security every moment to step up to the increasing threats that are developing in the ecosystem. So, as Jeff said, FreeRTOS has been the kernel has been a really important part of the embedded developer ecosystem over the last at least 10 years. It's been heavily used by a large number of ARM partners in developing their solutions. And it's exciting to see it stepping forward with the investment from Amazon to meet this challenge of improving security across the ecosystem. And we're very excited to be here at the beginning of that and to work with Amazon and AWS to drive a roadmap forward for this technology that will ensure that based on that secure foundation that ARM can contribute, the entire ecosystem can build secure and connected things to reach that 100 billion next devices over 4 years. Thank you very much.
So in addition to working with ARM, we've also developed a set of tools and support that make it easier for developers to use and have a consistent experience, regardless of what type of hardware they want to get started with or what IDE to get started with. So we've worked with IAR, who has a commercial-grade IDE for developers. Percepio, who has a trace analysis tool that allows for very easy visual debugging of code. And Wittenstein, I want to take just a second to talk about, because they've been a very long time supporter of the FreeRTOS kernel and have offered products which Dave will talk about in just a second. But I think they've really been on this journey with us, so I think it's pretty special what we've done together, and it really unlocks the potential for IoT, not just in consumer devices and industrial applications, but starting to look at things like automotive and medical devices, places where safety is mission critical. And so I'd like to welcome Dr. David Cowling on stage, who's the Managing Director of Wittenstein High Integrity Systems.
Thank you. Thanks, Rob, for that great introduction. And Thank you very much for being here today. It's a very great pleasure to be here. Now, we've all been hearing today about how much of an enabler Amazon FreeRTOS is. What if, though, you have problems, policy problems with using open source licensed code? Or what if you're developing a safety critical or mission critical product and you need formal certification or qualification? Well, at Wittgenstein High Integrity Systems, we've been partnered with the FreeRTOS project and, of course, Richard Barry for the last 9 years and more to provide solutions to meet these needs. And I'm pleased to say, with our new strategic business alliance with AWS, we'll be continuing to provide those solutions. OpenRTOS is our commercial license mechanism for Amazon FreeRTOS. Many customers of ours have found this very useful in the past when they had problems using open source license code. We provide full commercial support for OpenRTOS. And we also provide a service for the development of ports to processors that aren't available in Amazon FreeRTOS. We can also provide board support packages. And so OpenRTOS provides the fullest possible commercial backup to your use of Amazon FreeRTOS. We also provide SafeRTOS. SafeRTOS is provided to help users develop safety-critical and mission-critical products where formal certification and qualification is required. Wittgenstein High Integrity Systems have developed SafeRTOS using the same functional model as the FreeRTOS kernel. We performed a full hazard analysis on this model and formulated a full set of safety and functional requirements. And we used our safety-critical software development lifecycle to produce the code. After this, a respected and independent assessment was made of the code, and it was certified as compliant with international standards for applications in automotive, medical, industrial, and aerospace applications. You can also easily migrate from FreeRTOS to SafeRTOS because the APIs are very similar. And SafeRTOS includes many essential safety features that aren't provided in the FreeRTOS kernel. So, these features include task isolation and separation. This allows safety-critical code and non-safety-critical code to be located in the same memory space. You can use this to significantly reduce the amount of safety-critical code that you might require in an application. And of course, this saves a lot of development cost and maintenance cost. This feature can also be used to safely integrate the commercial standard AWS connectivity modules into a safety-critical design. FreeRTOS is also delivered with a full design assurance pack, or a design history file, that includes all the information from the development life cycle and the evidence of verification that allows it to be seamlessly integrated into your development project. This also allows you to flow smoothly from development into certification. So using FreeRTOS in a safety-critical development can significantly reduce timescale, cost, and risk. So at Winstein High Integrity Systems, we're very passionate about providing software to help with the development of edge-of-cloud devices. And the announcement today of Amazon FreeRTOS provides a great opportunity for OpenRTOS and SafeRTOS users. If you would like more information, please search for OpenRTOS or SafeRTOS on the web, and you'll find our website with a lot of technical information and downloadable demos. We're also exhibiting this week at the Venetian in Kiosk 20, and if you can make it down there to talk to us, it'd be great to see you there. So I'd like to thank you for your attention and your time, and I hope you have a great evening, and thanks, Rob, for the opportunity of speaking today. Thank you.
So we spoke first about accelerating the time to market and reducing complexity of the ecosystem. I think in part because of the challenges with each of those two things, developers have tended to over-provision devices. They'll choose a higher class processor just so that they are sure they'll get connectivity and they don't have to worry about the underlying functionality. To date, that's been a decent way to get to market a little bit faster. But in order to open up the possibility of IoT and microcontroller-based development, you need to bring down the ease of getting securely connected to the cloud. And in doing so, reduce the cost and impact both the bill of materials and to ongoing service costs. But I think the feature that I'm most excited to share about impacting costs is that in addition to the FreeRTOS kernel, Amazon FreeRTOS will be entirely free, entirely open source under the MIT open source license, and come with no commitments and no contracts with AWS. So it's a really easy way to get started. It comes with no commitments, and you're free to use any of the components that we've provided as you see fit. So you can pick specific libraries that are relevant to your use case. You can take just the kernel if that's what your embedded application requires. And again, it will all be free. So if you're excited about some of the things we've talked about and some of the features that Amazon FreeRTOS offers, there are several ways you can get started. Again, the Amazon FreeRTOS console offers an easy experience to get a download of Amazon FreeRTOS source code based on the supported hardware you choose and the libraries that are most relevant to your use case. But we've also made this available on GitHub. We've provided some updates to the freertos.org website, and that will remain the home of the FreeRTOS kernel. And we've also posted the update of version 10 of the FreeRTOS kernel to SourceForge. So again, I want to thank you for your time. I know we're very excited about Amazon FreeRTOS and excited to talk with customers about how you want to use it and things we can do to help you achieve your goals in IoT. So I'm happy to take maybe just a few questions up front, and then maybe we just, after a few questions in this format, then we can come up front. And if you have any questions for the partners as well, I'd be happy to offer that as well. Sure, over here. Yes. Microchip hardware will be coming soon. So we've worked very closely with them, and it will be coming in very shortly. Next couple weeks. Another one? Okay. Yes, so it depends a little bit on the architecture of your board. So some of the boards offload TCP/IP onto the networking processor. If you choose to run it on the application microcontroller, we offer a software library to do that. Oh, yeah, sorry. Do we offer a TCP/IP stack was the question. Again, the objective is that you won't have to access some of the underlying functionality. For example, if you're trying to communicate with IoT, you can just use the MQTT library, an agent, rather. But you do also have the flexibility to use just the library itself. Yep? No, so again, it's an integration that we've offered kind of out of the box, but because it's all open source, you're free to connect to any broker that you choose, and there's no commitment to connect to AWS or use any cloud services. Yep. So we have a PKCS11 library, which allows you to integrate, use features of key management. We haven't provided that integration with the hardware out of the box, so not today. So maybe I'll just take questions up front. We've got a couple other team members here, partners and customers, happy to answer questions. So anyone who's interested, just come up, feel free to chat. Thanks again for coming. So thanks again for coming. There are a few demos, both out in the Builder Fair. There are several demos available, and up in Copperleaf 5. Copperleaf 5. Thank you.